Hey guys, welcome back. Little technical thing I've learned. I know you might have had a little bit of issues with the volume on my last two videos. I noticed the first one, like I said, in the second video you had to push the volume up when I was over at the board, at the document camera, away from the computer. And then yesterday when I got the microphone from Mr. Carl, I had it on my desk knowing that I was going to transition back to there, so my intro and my exit was a little lower than expected. So now I have the microphone with me and I'll take it back and forth so you won't have any issues hearing me. Welcome to day 3. Today we're going to do a distance formula again, which we did yesterday, but this time we're going to talk about it in terms of story problems and remembering that we can substitute the rate and the time in order to multiply and divide as we need to. So here we go. Got my microphone. You should be able to hear me without any problems now. I appreciate your patience. We've definitely been on a learning curve with this technology and figuring out how to do all this stuff. So I appreciate your patience and I hope all is well with all of you, and here we go. So we're again talking about rate, distance, and time, and we know that our formula from yesterday is distance over rate or time equals rate or time. And we're going to look at this example in the middle here. I'm going to put a star by it. A commuter train is heading east at 50 miles per hour. A little train is heading west at 30 miles per hour. The trains are 4 miles apart. How long until we meet? Okay? So we know this is a distance formula question, right? But we have two different rates, no time, and their distances are combined, which makes things a little interesting. So if we look, and they have an explanation here, and I'm going to read it for you and you can look at it. We have to look at this problem logically. First, we're going to focus our attention on the little train. It is going to travel some unknown distance at 30 miles per hour, and we would like to know how long it will take this little train to get there. Okay? We know that the trains are going to meet somewhere, but we don't know where. Okay? We're just going to assume we're going to just put a spot there. Okay? And this is on page 23. And I'm going to go to page 24. So for this distance, we're going to substitute, as always, we are going to use a variable for what our unknown amount. Okay? So if the little train traveled X miles, and this is how far it is, and the entire distance is 4 miles, then the commuter train will have to travel 4 miles minus X miles. Okay? And that's because we're calling this the distance, and this is 4 minus the distance that the little train has already traveled. Okay? So we don't know how far this little train went, so we're going to substitute that for X. Alright? So, and again, this is a little more complicated than what we did yesterday, but we have our distance formula, and we know that it's distance over rate or time divided by rate over time equals rate or time, and we're solving for it. So we know that this first distance is 4 minus X. Okay? And we know that the little train is traveling 30 miles per hour, and we know that the commuter train is traveling at a rate of 50 miles per hour. So we don't know the time. That's what we're trying to determine. So we've got 4 minus X over 50, and then X divided by 30 equals T. Okay? So on this one, what we're going to do is we're going to multiply both sides by 30, because this is a division and we want to get rid of it and we want to use the variable isolated. Okay? So we know now that the little train traveled 30 times t miles, right? So that means that the big commuter train traveled 4 minus 30 times t miles. We've just replaced that x with this 30t because this is what it is, the amount. Okay? And I'm going to go to page 25 at the top. So now we have an equation. So we know that x equals 30t, right? So now we have to combine these two equations so that we can try and solve it. So we've got 40 minus 30t over 50 equals t. And we're going to combine. So we're going to isolate. So this becomes plus 30 plus 30, right? And so these become 0. So we end up with 4 equals, and 50 plus 30 is 80. So 80t. So now what we have to do is this becomes a division problem, right? And so these are going to go away because 80 divided by 80 is 1, or just our variable, which is t. And if we have this, which is a fraction, we can reduce that down to 1 over 20th, right? Because 4 times 2 is 8, so 4 times 20 is 80. So now we have t equals 1/20th. So what does that mean? We've gotten to this point, so what do we do with it? Alright, so 1/20th is the time it will take for the trains to meet each other. 1/20th of an hour. Okay? So, but what is that? Well, an hour is 60 minutes. So we want to know how much is 1/20th of 60. Alright? So we have this situation here. We have 1/20th times 60 over 1, because this is in essence 60 minutes. We've just turned it into a fraction. And we know when we multiply fractions, we multiply across. So 1 times 60 is 60, and 20 times 1 is 20, okay? Or 6 over 2, because we know from our previous lessons that we can get rid of those zeros, and then we do a simple division problem. If you divide 6 by 2, you get 3. And so it takes 3 minutes for them to get to where they need to be. Alright, let's look at this one. Anita drives for 5 hours at some unknown speed, and then she speeds up by 10 miles per hour and drives for 3 more hours. She traveled a total of 430 miles. What 2 rates of speed did she travel? So what's the first thing that we're looking for? We're looking for an unknown. 2 rates of speed, right? So that becomes what 2 rates of speed? So that becomes our x. So we're trying to solve how fast she went at each of those 2 turns. And I'm going up to page 26. So we're going to substitute x for the first speed. And how long did she drive that fast? She drove x miles per hour for 5 hours. Then she sped up and drove 10 miles per hour faster for 3 more hours. So that would be written as x plus 10 miles per hour, right? And they've given us a picture, which, you know me, I love pictures. I think it represents our math very, very well. So we know that she drove X miles per hour for 5 hours, sorry. And we know she drove X plus 10 miles per hour for 3 hours. So looking to find the rate that she started with for 5 hours and the rate plus 10 for the additional 3 hours. And we know that the distance that she traveled overall was 430 miles. Again, we have our distance formula. I'm going to move this up. So we know that the distance is 430 miles, right? And then we have the rate and the time. So we need to fill in the rate and the time. So the rate, right? The first portion, is 5 hours times X, because we don't know how fast she drove. So now we have 430 equals 5X, right? And I'm going to go to the page 27 at the top. So the second part of our problem that we need to figure out is she drove X plus 10 miles per hour for 3 hours. So we're going to multiply her base rate, which we're going to solve, times 3 for the amount of time plus 10. And now we're into an algebraic equation, because we have 5x plus 3 times x plus 10. And we all remember the distributive property, and we know what we have to do is combine. So if I'm using the distributive property, 3 times x equals plus 3x, and 3 times 10 is plus 30. Now, we can combine these two because the variables match. So we have 5x plus 3x. So that becomes 8x plus 30. And again, we're going to swing this over. So if we subtract it from this side to get 0, we have to subtract it from this side, and we get 400.
Good morning, everyone. I just wanted to remind everybody that before you leave today, you need to make sure that all of your classes are uploaded, your videos are ready.
Alright guys, sorry, can't control when I'm recording a live video if somebody comes over the intercom. So, we've done this step. 430 minus 30 is 400. So now we have 400 equals, and we've isolated this 8x because we've subtracted here. So now what we have is 400 equals 8x. And again, we're going to divide both sides by 8. So if we were doing it we would do it like this. These go away, and then we have 400 divided by 8 equals x. And when I do 400 divided by 8, I get 50, right? So we have a rate of 50 for x, but we're not done. I know, you wish we were done, but we're not. Sorry. So now we have to solve for x. So what are we going to do? Well, x is 50. So she drove 50 miles per hour for 5 hours, and then she drove 50 plus 10, which is 60 miles per hour for 3 hours. So what have we done? Well, We've just figured out how fast she drove. Feel free, again, if you need to, pause, stop, go back and relook at things if you need to. All right. We're going to go to the top of page 28. So the distance formula isn't just used for traveling types of problems. So it could be used for other things as well. The rate doesn't have to be miles per hour. As it says here, it could be the number of lawns mowed per hour or the number of books read per day. So it doesn't have to be necessarily a distance problem. It could be a rate. So let's look at this problem. Esther can peel 4 tomatoes per minute. How long will it take her to peel 68 potatoes? Alright, so we have the distance over rate equals time. And the rate is how fast that Esther can peel potatoes. Well, she can peel 4 potatoes per minute. And we know that this is a ratio of 4 to 1. Okay, or 1 minute for 4 potatoes. So we're going to substitute that for our rate. And notice we've put it where our rate would normally be. Okay, so we're looking for the time it will take to peel 68 potatoes. So we could substitute 68 for the distance part of our problem. And our time is our unknown. So we have t for time. So we know if I divide 4 by 1, I get simply 4. So this new equation is 68 over 4, or 68 divided by 4, and 68 divided by 4 is 17. So it's going to take Esther 17 minutes to peel 68 potatoes at the rate of 4 potatoes per minute. Going to the top of page 29. And they're going to add a little bit to this. It says, now let's say Esther gets some help. Her mom, Keisha, has a fancy automatic potato peeler that can peel 13 potatoes per minute. Now how fast can the two of them peel 68 potatoes together? Right? And again, it really is not a big deal because we're going to add these two together, right? Because my denominators match. So 4 plus 13 is 17, and 68 divided by 17, it's 4. So it will take 4 minutes for the two of them to peel those 68 potatoes. Alright, going to the top of page 30. Trinity walked to town at a rate of 4 miles per hour. She rode the bus back at 40 miles per hour. The town is 2 miles away. How long did it take Trinity to travel to town and back? So, the distance is 2. We don't know the time. The rate is 4. So this first one, we're going to divide 2 by 4. And if I divide 2 by 4, I get 0.5 equals t. But she rode the bus back at 40 miles per hour. So this is hold on just a minute, guys.